Welcome to physics class by Anjan Kumar J. I'll be starting a series under pre-university physics. This will help you to understand the concept much more better than your classroom discussion. Under pre-university physics, let me start with the vector analysis. Before getting into vector analysis, let me define what you mean by physical quantity. Then we'll classify the physical quantity. Then we will end this class with a representation of vector. Now, let me define what you mean by physical quantity. The quantities that are measurable or the quantities that are physically measurable are called physical quantities. Length, mass, velocity, time, distance, displacement, amount of substance, acceleration, force, pressure. Many more things can be listed under physical quantity. This physical quantity mainly classified into three types: scalar, vector, and a tensor. Scalars are the physical quantity, one which have only magnitude. Mass, distance, time, flux, speed. These are the physical quantity which can be listed under scalar. So let us consider the mass as an example, then we will move on to the vector. Let us understand what is the scalar. That is, if you go to a retail shop, if you buy 10 kg of rice, here the substance is rice. How much you have bought? 10 kg. That will give you the magnitude. The amount of substance will give you the magnitude. Such physical quantities can be listed under scalar. Vector. Vector is also a physical quantity, but it has magnitude, direction, and obeys vector law of addition. Yes, I understand that the last term, that is vector law of addition, is not mentioned in your textbooks, or your class teacher may not have discussed or may not have mentioned in the classroom as well. But the actual definition for the vector is physical quantities which have magnitude, direction, and obeys vector laws of addition. Let me give you an example for this definition. Let me consider a conductor which is connected to a battery, external power source. Let us say the electric current is flowing from left to right. That means it has a direction. See, we have directed the direction of an electron, or we have given, or the electron has a direction, one which is from left to right. It has a direction from left to right. And we will be measuring the electric current as 1 ampere, 2 amperes, so like that we will be measuring, that is microamperes, milliamperes, like that. It do have a magnitude. It has a magnitude, it has a direction, and we do not call it as a vector. It is not a vector. It's a scalar. So, in order to call any physical quantity as a vector, it should have magnitude, it should have direction, and it should obey vector law of addition. Here, though the electric current has direction and magnitude, it does not obey vector laws of addition. That's why it's been listed under scalar. If the physical quantity obeys vector laws of addition, then it will be listed under vector. For that, velocity, force, momentum, torque, displacement, these are the physical quantities, one which has magnitude, direction, and they obey the laws of vector addition. That's why they have listed under vector. Tensors. These are these also a physical quantity. This also a physical quantity, one which does not have any specific direction. It does not have any specific direction, and it has different magnitude in different direction. So such physical quantities will listed under tensors. Examples are moment of inertia, stress. Just because we have mentioned that a scalar quantity is just has magnitude doesn't mean that it will always carry a positive, or else you can just call it as it will always be a positive quantity. Sometimes scalars will also be negative. One of the best example as well as simplest example that I can give you is charge of an electron. Charge of an electron is minus 1.602 into 10 power minus 19 coulomb. Here 1.602 into 10 power minus 19 is the magnitude and it carries negative charge. Sometimes scalars will also be negative. Scalars may have direction, like we have discussed, electric current has a direction, but it will not be listed under scalar. I mean vector, it will be listed under scalars. Surface tension is also a scalar because it has unified direction. Let us move on to the representation of vectors, where we can represent the vectors in two ways. That is analytically, graphically. Analytically, any letter, any alphabet, that is, it does not have to be a capital one or a big one. It can be a small one as well. That is, a capital letter or a small letter, one which has arrow on it, will or can be represented as vector. So in order to know the magnitude or in order to calculate the magnitude of such vectors, we have to get a mod of vector, that is sandwiched between two parallel lines. It's called mod of vector A or simply A. Graphically, how do we represent vector graphically? As we have shown, we have drawn a straight line with a arrowhead, or else you can just call it as an arrow, OP. Here, O is the tail origin of a vector, and this arrowhead is called head terminal of the vector. Here, OP represents the vector A. OP represents the vector A. The length of this arrow will give you the magnitude. The length of this, that is OP, will give you the magnitude of the vector, where this arrowhead, direction in which it is headed, will give you the direction of this vector. So for now, we have defined scalars, vectors and tensors, and we have defined scalar briefly, or we have understood scalar, then we have represented the vector. From next class onwards, or in the next class, we'll see the classification of vectors or types of vectors. Thank you.